This is a compilation of old derivative questions from your AP test. I need y'all's attention. Come on, distractor. Focus. All right. So I don't want that. Where do I want it? Oh, I don't want that either.
I really don't care.
All right. So, guys, these are old AP questions from prior AP tests. They're actually pretty old, but they're a lot of them pretty good at giving you a taste of what you might see. Now, remember when you take the AP test, don't think, oh man, I did 20 problems and I got 10. I'm dead. That's half. You get half the points on your AP Cal test, you make a 4, roughly. Okay, so there's 108 points. Usually it's about a 55 or 56 is a 4. Usually about a 68 to 72 is a 5. And usually it's a 39 to a 44 is a 3 out of 108. And keep in mind, half of it's multiple choice, of which you're going to get a fourth of those if you are a blind squirrel. Okay, so I mean, it's not as hard to pass this thing as you might think. All right, but they are always little subtle nuances. Some of them are very straightforward. The problems, some of them they're like, wait a minute, and you have to logically work your way through it. And it's a pretty decent test. Teaching to this test makes sense because it's pretty thorough. You have to have a pretty good understanding of calculus and what it entails to do that. So there might be a problem or two on here that's a little above your pay grade, but there are elements to the problems that I like. But our job is we're just going to go through as many of these as we can today, and whatever we don't have, you can work on for homework. So first one, number 1, f of x equals that. What would the derivative be? Okay, so if you are applying the quotient rule, then the derivative of x would be what? Tell you what, let me zoom in on this thing. Okay, so the trick is not so much in the derivative, but it is in the simplification, because they're not going to leave it all ugly like we're doing it a lot of the time. So here's my low. Derivative of the high would be what? E to the 2x times the derivative of 2x, which is 2, minus high derivative of the low times 2 all over the low squared, which is 4x squared after you simplify. So cleaning that up, I end up getting 4x e to the 2x minus 2 e to the 2x over 4x squared. But you can see that they've simplified this. So what does it look like that they've done?
E to the 2x out of the top.
Maybe even a 2 e to the 2x out of the top, leaving me a 2x minus a 1. And then canceling that 2 gives me a e to the 2x. That could be true on b, d, and e. 2x minus 1 looks like e, and then over the 2x squared. So it looks like we're dealing with e here. So that to me would probably have been one of the very first questions on your AP test. Pretty basic, pretty simple, not overly challenging. But anyway, that's an example of something you might see. Here's number 2. Let f be a function such that blah, which of the following must be true? Now, they're expecting you to see something with this. What do you see? The definition of a derivative. That's what they're expecting you to see. Of what?
Of f of x.
At
2.
So what they're saying is this, you're supposed to be able to look at this and say, the derivative of f, that means the derivative function. And that's the f function. They're expecting you to say the derivative of f when the x value is 2 equals what? 5. So if I said that, what can you deduce from f? First thing, can you deduce that f is continuous at 2?
Yes.
Why?
Because Because if it's a derivative, it's continuous.
Because if it's differentiable, it's always continuous, right? And it clearly is differentiable because I took a derivative at 2 and got 5. So yes, that's true. Number 2, f is differentiable at 2. Well, I hope so, because literally that's what the statement is saying. All right, number 3, the derivative of f is continuous at 2.
No, because there's not.
What do we even know about the derivative of f?
We don't know. We don't
I'm
know.
sorry. Yeah, I know it's 5, but do I know something about the continuity? Give me 2 seconds for a second.
Constant.
Give me 2 seconds.
There's
The
literally-
derivative.
Well, yeah,
There's
let's say
not an answer
it has
to
to
this.
be. It has to be a Z.
Yeah, it
Because
has to be.
if 1 and 2 are true, there's no answer that's.
Hold on one sec. Derivative. Trying to find an answer to this. No, I can't say 3 here. I know about f. I know about the derivative of f, but I don't know about the derivative f's continuity. That's the problem. So I got to go with just 1 and 2 here. Not to mention that 1, 2, and 3 is not even an option, right? So I got to go with just 1 and 2. But again, kind of a little odd, but I don't know anything about, I know that this is the derivative of the f function, and I know that it itself exists, but I don't know anything about the derivative's continuity. Like, for instance, there might be something about the derivative function. How do I say this? I'm going to process this a little bit more and think and see if I can come up with a better explanation. But I know these with confidence are true. And that alone tells me it can't be 1, 2, or 3 because it's not an option. But I'm going to think about that a little bit more. Jump to number 3, and we'll come back to it if we have time. Let f be the function given by that. This would be a calculator problem. For what value of x is the slope of the line tangent to f equal to 3? Now think about it. What is the slope of the line tangent to f? The derivative. So they're asking you, when would the derivative of that be equal to 3? Now here's the thing. Do y'all hear that? That's what that's saying. So where's the slope of the tangent line graph of that? So where is the derivative of that? That's the slope equal to 3. Now manually, here's what people do. And granted, we have not talked about this, but this is something you'll have to learn to do. Manually, we would say, oh, well, the derivative of f would be 2e to the 4x squared. That's basically copy it down. Times the derivative of the exponent. That's the chain rule. That gives me 8x. And I want to know, where is that equal to 3? Does that make sense? Where would the derivative, slope of the line tangent to that, be equal to 3? I don't know how to solve that manually. Like, I do not have the math skills, nor do you, to solve this manually. But I do have a calculator. And if I have a calculator, I can graph this equation. I can graph it as 2 equations and find the intersection if I want. I can essentially think like this. I could let y equals that, and I could let y equals that. I could basically separate it. And if y equals that and y equals that, then since they're both y, it makes sense that these are equal, right? I could graph that equation and graph that equation and find out where they intersect. And that would be the value of x where this exists. And you have a graphing calculator, you could do that. Now, lately, I haven't been teaching kids to do that. I've been teaching kids just to do this. If you have an equation like this, just move the 3 to the other side, right? And make one equation. And then just replace the y with the 0 and graph that. And literally go and look at the graph and find where y was 0, which is the x-axis. And you can graph it. Now, when you really get solid with your ability to use your calculator, you won't even bother. And we haven't talked about this yet, but I do have a day to talk about graphing using your calculator to find derivatives. Your calculator cannot find the derivative equation for you, but it can find a value of a derivative, and it can graph a derivative equation. So when you get really solid with your calculator, what you'll do is you won't even do this. You'll hit this button on the calculator that says ddx. You'll type in your function, actually, you won't even do this part. You'll just type in your function and you'll just do this. Basically, you'll move the 3 over and you will graph that. Y equals, and you'll literally hit the DEX button, type in your equation, and the calculator will do the derivative for you. Which that gives you the advantage of if you accidentally forgot a rule, you wouldn't have to know that rule because the calculator will do it for you. Figure out where the derivative minus 3 is 0, and you can go and solve and find the solution to the x-intercepts. Y'all with me? Anyway, we'll get to that later, but that's something that you'll do. Probably a third of your AP test will be calculator based, and that's something that you might do with a calculator. All right, look at number 4. If f is that, then what's the derivative? Notice you don't see any fractional exponents, do you? Which is why I don't like you changing that to the 1/2 power and doing it that way, because it just makes it a lot more work for you. And if you just learn the rule, whenever you have a square root, you just think about it like that, you're going to be as a square, you're going to be a lot better. Now, this is going to get a little uglier because what's going on here?
Where'd you say? Product.
You got a product rule. So check this out. The derivative is going to be first times the derivative of the second. Now, what's your rule for the derivative of the second?
2 times
Double that radical on the bottom, derivative of the inside part on the top. So first d second plus second times the derivative of the first, which would just be a 1. Now, I get that. That's great. I can even simplify this a little bit if I want by canceling those 2's out. But what do I do here to try to get what I have here? Common denominator. So how do I find the common denominator? The top and the bottom by root 2 minus 3 under the radical, which would give me a root 2 minus 3, sorry, root 2x minus 3 under the radical on the bottom. And what does that give me on the top? Just a regular. That would make the radical go away and give me a regular 2x minus 3. So at the end of the day, I get a 3x minus 3 over a root 2x minus 3. Must be A. Now, let's just say you couldn't simplify. Is there a strategy you could use to try to check to see what your answer is? Let's just say, pretend you're like, I have no idea how to do this. I can't go from there to there. What would you do?
approximate,
What do you mean approximate?
like approximate an answer to that.
Not closest. Exact.
Exactly.
Like, couldn't I just pick a number? Like, but yes, you just kind of, I look at it and go, I would try to pick a number that's really nice. Like, if I plug x equal 2 in, what do I get? 2 over 1 plus 1. So 2 plus 1 is 3. If I plug a 2 in there, what do I get?
Say
3 over 1, which is 3. I plug a 2 in there, what do I get? 2 over 1, which is 2. 1 over 1, which is 1. 1 over 1, which is 1. 4 over, actually right here, you get 4 over 2, which is, well, 2. So the only one that gave you 3 was this one on the top. So you could kind of just work with it that way. And that is something that I would encourage you to do if you ever struggle with the simplifying. Because I have lots of people, including on the calculus students we were working on yesterday, we do integration a little bit differently. And the answer was written a little differently. And a lot of people had it right, but didn't know how to get simplified to match. And I'm like, couldn't you just plug a number in and kind of figure it out that way? And they're like, oh, yeah. So if you have to guess, check, and revise, do it. But this case shouldn't be that bad to simplify.
after derivatives, like what else is like calculus? Is it just like harder derivatives?
No, the derivatives we're doing are harder now than they probably will ever be. Applications of them. Like, why do we want to know about slopes? Well, like, what if I asked you, hey, how do I maximize the area of a box from a piece of cardboard? You know, like, for instance, if I had a big piece of cardboard, not area, volume. I have a big square piece of cardboard and I'm going to cut out corners and fold up sides or whatever. How would I maximize the volume? Well, you could create a volume equation. And when you take a derivative, it talks about the rates at which it changes, right? Well, the rates at which it changes are slopes. If I have an area equation will kind of show the curve of area, or a volume equation would show how the volume reaches maxes or mins, right? what do you think happens at a max volume in terms of slope?
Zero.
It's 0. So if I came up with a volume equation, I could take a derivative of it, set it equal to 0, and find where that volume hit a max. Is that kind of making sense? Like, what if I created a volume equation that I used x for the side, and I had like, okay, well, this side's x, and this side's 2x, and the height's 3x, or something like that. I could figure out what x maximized volume, and then I could plug that x back into my area formula to figure out the length, width, and the height that I needed to maximize volume. I mean, that's a simple little example, but that's a whole study called optimization. And optimization is something we do. We figure out how do you minimize costs or maximize profits or minimize whatever, maximize volumes, whatever it is. But that's a study we do of derivatives. Related rates is a study we'll work on with related, how different variables change with respect to each other. And then we do antiderivatives, which is going backwards, which is integrals. And then we do a whole study with those. Anyway, what about number 5, guys? Pretty basic, I think. What would you do first in this derivative? Now, you'll notice right here, this cosine right here, this is the same thing as me writing something like y equals cosine squared of x cubed. And if I had that, I would dy dx. Well, this is y. So if I took the derivative of both sides, I would have dy dx, and then I would ddx that cosine of x cubed and get something. Well, I'm skipping this part, and I'm just saying ddx that. So you don't write your answer as equals y equals or anything like that. You're just taking the derivative of that, writing your answer. It's not an equation, so you don't try to turn it into an equation where you took the derivative of both sides. It's just one side. So what do you begin with? So you're going to go 2 cosine of x cubed. That takes care of your 2 times negative sine of x cubed, and that will take care of your cosine, times your 3x squared. And notice that they took the 3x squared and the 2 and did what? And you can see they kind of baited you in with this negative 2. If you forgot the chain rule, oh, negative 2 must be e. So that, if you forgot the chain rule at the very end with the 3x squared, but it ends up being a negative 6x squared, hence d. What about, there's a couple good ones in here somewhere. Okay, this is another calculator problem. It says, which of the following is an equation of the line tangent to that graph at the point where the derivative is 1? Which of the following is an equation of the line tangent to that at the point where the derivative is 1? Do you know the point where the derivative is 1?
Yes.
You do?
Find it.
Can you find the derivative of the
Plug in the one.
equation in that one?
Okay, I'm gonna write what you said, and then I'm gonna clarify, because you're saying one thing, but I think you're meaning this. They said, could you find the derivative? I heard this. Could you find the derivative? And finding the derivative would give me 4x cubed plus 4x. And then you said plug in 1, but did you mean plug in 1, or did you mean set it equal to 1? Because if I knew x was 1, then I would have the x coordinate of the point, wouldn't I? And I could just plug the x coordinate of the point right in there and get the y coordinate. I don't know the x coordinate. All I know is the slope is 1, and that's the slope. So if I set that equal to 1, can you solve? Now again, you guys aren't trained. You're trained to go, oh, polynomial equal to 1. I guess I need to pull out synthetic division. Start checking my possible rational roots. But if it's a calculator problem, what can you do? You can graph it. You can either graph the left side and graph the right side and see where they intersect, and that would give you an x coordinate. Or what I do is I just move that 1 to the other side, replace the 0 with a y, graph, and solve for x. And whatever x I get, what would I do with that? What do I do once I find that x? Because I need to find the equation of the tangent line. What do I need for an equation of a tangent line? A point and a slope, right? I already have the slope, right? And so that means you, right there, you know it's not this because the slope is 1. But that doesn't eliminate a lot of your options. right?
Right.
But I need now the y coordinate that goes with that x. So I got to find that x, whatever it is. How do I get the y that goes with it? Plug it back into what? Back into my f, right? Plug that x value back in here to get my y, and then take those 2 points with my slope, plug them in here, and see which one it matches. Are y'all seeing that? So I don't remember which one it was, but do y'all see that process? Now, these calculator active problems are not things we're going to do on our test. Don't worry about that. But these are the things that you would have to be ready to do. Look at 7. Is 7 the one that gets filthy? Oh yeah, I love 7. Okay, not a ton of people got this one because people get stuck on something instead of accepting what they're giving you and moving on. So let f and g be differentiable functions with the following properties. Okay, first of all, if I tell you they're differentiable, then you also know they're continuous. So g, it says g of x is greater than 0. What does g of x mean? It means the y values of the g function. Do y'all get that? If I said g, g means the entire function, right? If I said g is this, then that would mean g is like the whole, the idea, the whole y equals blah, 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 x, and that's the whole thing. But if I say g of x, I mean the y values of that function. Just like if I say x, I mean the x values of that function. So I'm saying the y values are greater than 0. What does that mean to you? The y values are all greater than 0, then the graph is located where? Entirely above the x-axis in the first or second quadrants. Okay, so we know that about g. Then it says f at 0 is 1. What does that tell you? A point. That tells you the f function definitely crosses at the point 0, 1. Okay, so those are the only 2 things I know right now. Then they said this. If h is this, and this is where people get frustrated a lot of times. Come on. If h is fx times g of x, then h prime of x is f of x times g prime of x. Now, wait a minute. I thought h prime of x was what? The product rule. And the product rule is first d second plus second d first, right? But they're telling me that the derivative is just this. Now, a lot of people right there went, I don't know what that's bizarre. I don't know what to do there. Let's think about what they're saying. If they're telling you that the derivative is just what I boxed, but you know the derivative is the whole thing, then what can you deduce? That one of these has to be what? Has to be a 0. But wait, what do you know about g? It's greater than 0. So the g can't be 0, can it? Because it has to be positive. So what do you know then? That the derivative of f of x is what? It didn't say the derivative at 3 was 0 or the derivative at 7 is 0. It said the derivative of f is 0. When? Always. So if I know the derivative of f is 0, and I also know that the value of f at 0 is 1, you told me that was a point, right? If it has to go through there and the derivative is always 0, then what do you know about the function f? It has to be a horizontal line. Y equals 1. So what is f? That's a problem where you have to take what they give you, not assume the position, and just continue to put it together, read through everything, know what the little terms mean. And that's a learning curve. If you looked at that and went, well, that wasn't that hard. Great. But if you didn't, and you're like, ugh, that's an example. And again, you don't have to get all of them right to make 4. You get about half, right? 2/3 right to make a 5. All right, number 8. Any ideas for the derivative? Cosine of blah. So I got cosine of e to the negative x times what? The derivative of that, I'm going to put it up front, times e to the negative x times a negative 1. Right? That's a big chain rule. Deal with the sine, deal with the e, deal with the negative 1. So this is me dealing with the sine. This is me dealing with the e. This is me dealing with, here's me dealing with the negative x. And you can see that right for e. I'm getting bored with these. Hold on. Let's look at number 10. Not that that's really brutal, but look at number 10. What's the derivative of tangent of 2x?
Secant squared.
So the derivative of tan 2x is so slow. Is secant squared 2x times a 2. So how do you find how do you find 2 secant squared of 2 times pi over 6?
That's pi over 3.
So that's pi over 3. How do you find 2 secant squared of pi over 3? What do you do first? You find the secant of pi over 3, then you square it, then you double it. So I find secant of pi over 3 by looking at the cosine of pi over 3. What's the cosine of pi over 3? Over a half. If that's cosine, what's secant? 2. Square the 2. 4 multiplied by 2, 8. And if you don't know your unit circle for the AP test, you're at least take 1 point off your score, minimum. And you don't have to know like sine of 24 pi over 6, whatever. You don't have to know really ugly ones, but if you don't know first and second quadrant unit circle values, you're dead. All right. All right. What about 11? That's implicit differentiation. You don't know that. What about, that's boring. What about 13? Okay, so the derivative of that, first I'm going to find that. The derivative of f is, how do you take the derivative of a natural log?
It's yeah.
Copy that junk to the bottom.
And derivative inside.
And then the derivative of that, the chain rule. So when you put it on the bottom, technically there's a 1 on the top. And then you would multiply by the inside part. That would be the chain rule, except I put that on the top. So the derivative of that part would be what? 1 plus nothing. And then what? Copy it down times a negative 3. And you can put the negative 3 at the end. And then it says find that derivative at 0. So the derivative at 0 would be what? What's e to the 0? 1. So all you have left on the top is 1 minus 3. And on the bottom, when I plug a 0 in, I get another e to the 0, which is 1. 1 and 4 is 5. 5 plus nothing is 5. And you get a negative 2/5. All right. 14, kind of boring me. Slope of the tangent, 15. When I say implicit, don't do 15 either. That's implicit. So the 2 that I mentioned implicit about, we don't know how to do those. The slope of the line tangent to the graph of that, at x equals that. That bores me. All right, what about this? 17. Which of the following, at f be the function given above, which of the following statements are true about f? And when they say true, always true. Number 1, the limit exists as x approaches 3. How would I check that?
Check the sides.
Yeah, the left and the right have to be equal, and which means the limit would exist. The value would exist, right? And the limit and the value would be the same. Those are the 3 points of continuity. You know what that really simplifies to? The left side and the right side and the value all have to be equal. So check the left, check the right, check the value, make sure they're the same. So what's the limit from the left? Limit from the left is 5. What's the limit from the right? 12 minus 7 is 5. What's the value? 5. So definitely it is, definitely it's continuous. I was checking continuity, number 2. Oh, and there goes my pen. Awesome. There's number 2. I know that. And then also I knew the limit exists because I just checked the left and the right. So definitely 1, definitely 2. Now then it says f is differentiable at 3.
You have to make the derivative
So I could make the derivative equation, right? You know those days.
Happy Friday.
That's right. I'm not gonna let this get me down though. No chance. Friday. Drive.
Sorry.
What page is this?
It says random thing.
Yeah.
Oh, crap.
You, I said that. Sorry, Maddie. Might you
And
Oh, and that.
pen's back. Sweet. Okay. Okay, so to check is it differentiable? It had to be continuous. I've already checked that, right? Now you might go, oh, and it is 1, 2, 3, so it's totally possible. If it wasn't even 1, 2, 3 possible, I would just go with 1, 2 and cut and not worry about it. But anyway, right here, I got to check the derivative function. What's the derivative function from the left side? Always 1. What's the derivative from the right side?
4.
Always 4. Not differentiable. Just 1 and 2. All right. 20 intrigues me. Let's look at number 20. We're going to hop over to the right. If y is the natural log, what would be the derivative of y with respect to x? So you got a, I'm going to what's called y prime. So low, what's the derivative of the high? 1 over x minus high times the derivative of the low. What's the derivative of the low? 1 over the low squared. So what do I end up with? 1 minus ln x over x squared. Isn't so bad. Scrolling down. Actually, did I skip some stuff? I skipped some stuff. Look at 18. Is that interesting? Not really.
22.
What about 19? Let f be the function defined above, where c and d are constants. If f is differentiable at 2, what would be the value of c and d? And remember, a lot of people miss this or get stuck on this because they go, oh, if it's differentiable, then the slopes match. But the slopes could match, but it'd be separated, right? Now, not if it's differentiable, but the point is to make sure that it's differentiable, I have to make sure it's what? Connected or continuous. So I got to check continuity and differentiability. If I just check differentiability, I'm going to get one equation that will probably help me solve for C, but I'm going to be like, where did the D value go? So I basically have to check both. So what would I do if I was checking continuity? I would say the limit in the left and the limit in the right and the value are all equal. Well, that's basically saying that CX plus D, when X is 2, so what does that mean? That 2C plus D would have to be equal to what? 4 minus 2C. Are y'all seeing that? That is essentially me checking continuity. That's the limit from the left and the limit from the right and the value are all equal. And I'm not showing all my work, but if I was showing all my work, I would write the limit of f of x as x approaches 2 from the left is 2c plus d. The limit of f of x, I would write all that stuff if I was trying to be clear to the AP reader. I don't need to do that on a multiple choice. Now, I can't solve for this at all. Now, I can add the c over if you want and make a prettier looking value. So I could do that if I want, but whatever. Then, what do I know about differentiable? What would be equal? The derivative function. I have space just over here. So the derivative function of this would be what? C plus nothing, and the derivative here would be 2x minus c. So if the derivative from the left and the right are equal, that would mean c would be equal to what? 4 minus c. Because again, I'm doing this at x is 2. Well, that works out nicely. Now I can solve for c, plug that 2 in, and solve for d. So what is the value of c plus d? -2. And we did a problem like that. We had a bonus on our test. We did one like that yesterday, the day before. It's very, very common for that to be an AP question. We did 17 already? Yeah, did we done? Okay, jump to, I like these charts. We haven't done enough charts. Here we go. Look at number 24. No, I like second derivatives too. Look at number 21. 21 is saying what?
Take the derivative of the derivative.
Take the derivative of the derivative. So I can't shortcut that. I can't jump from the first to from the function to the second derivative. I got to go through the first derivative. So let's just start by taking the dy dx. So what is dy dx? It is what? Drop down the constant. All right, I always do that if I have 2 times. Just drop it down, unless there's a power to work with. So the derivative of the cosine would be what? I'm going to put the negative in front of the 2 and just put sine of that. Right? Y'all see that? And then times what?
X over 2.
Times
1.
the derivative of x over 2, which would be a half. So the half just what? Cancels out that 2. Y'all seeing this?
Would it not be 1 over 0?
The derivative, because that's 1/2 x, right? Think of it as 1/2 x. I can do low d high and get 2 minus high d low is 0 over the low square, but that's going to give me 2 over 4, which is 1/2. So it's, if you ever see something like this, guys, just think of it as 1/2 x, and then the derivative is pretty easy to see, right? It's just a constant. So me dividing by 2 gets rid of that, and this is all I have left. And I probably want to simplify this because I'm about to have to take the second derivative. Are y'all seeing that, guys? Everybody with me?
Yes.
Okay, so now when I ddx this again, and this is essentially what I'm doing, I am ddxing. First, I ddxed the y. Now I'm ddxing, forget this, I'm ddxing both sides again.
What's the hurry?
How is there
negative sign?
How is there an X left
Yeah,
over?
Oh, I have no idea why there's an x in there. Sorry, there shouldn't be. There's no x there. Sorry. Thanks for speaking up. Are y'all with me? Okay, so now I'm ddxing that. Well, that's why that you have this funny notation. D squared y, like d squared y, and then dx quantity squared. That's what that is, dx quantity squared. They just don't write it as a quantity. It's just assumed you know that. So basically, that's the second derivative. That's why the notation looks like it does. I think we've talked about that. So what's the derivative of negative sine of blah? Drop the negative, right? That's the constant, like -1. The derivative of sine of blah is cosine of blah times a what?
1/2.
1/2. So you end up with -1/2 cosine of x over 2. And they didn't want anything other than that, so I am done. All right, look at 24. I like these little table problems. It says the table above gives the values of f prime, g, and g prime at selected values. If h is the composite function f of g of x, then what would be the derivative of h at 1? All right, so first thing I need to find what? The derivative of h, and then plug the 1 in. And when you're writing this out, and it's not a multiple choice, guys, label what you're doing. So the first thing I'm going to do is I'm going to find the h of x. Sorry, the h prime of x. So h prime of x tells me to do the what? And this is a typo. They should have an extra parentheses right there. So I got to be doing the derivative of that. So you start on the outside function like we always do, and do f prime. Anything on the inside be considered a blah. So f prime of the g of x. That takes care of the f part. Then we go to the inside part. The derivative of g of x would be g prime of whatever's on the inside, which is the x. That takes care of the g. And then whatever the derivative of x is, which is 1, I would do that lastly. I don't write anything for that on this because I don't have to bother doing that. And then for h prime of 1, I come in here and I plug a 1 in. But guys, don't look at this as a product rule. It is not a product. Now, this is a product at the end, but I don't have to take the second derivative. So what do I do first for this?
Plug in.
So find that g of 1. So g at 1 is -1. So I'm going to replace that with a -1. And then I'm going to find the derivative of that. And the derivative of f at -1 is 5. And then I can find g prime of 1, which is 2, and I can bring that down. But I got to do a composite just like I always do a composite, right? Make sure you can do these. This is very, very common for AP to give these tables. They love the crap out of some tables. All right. All right, what about All right, number 2 looks slightly odd. 22. Let's look at 22. By the way, don't do 23. That's implicit also. 22 says take the derivative of f. So what do you do for a derivative of e to the block?
Copy down to E.
Copy it down. And then what's the derivative of 2 over x?
2.
Derivative of 2x is 2. What's the derivative of 2 over x? I see a fraction.
Oh, negative 2.
You got 2 options, guys. One option is to treat it like that. 2 over x is that. And you could just go negative 2x to the negative 2. So if you want to do that, negative 2x to the negative 2, and then clean that up, that gives you a negative 2 would stay on the top. E to the 2 over x would stay on the top. And that x squared would come down to the bottom. And I'm only doing that because I have to probably make it match to this. And it's going to match with that one right there. Right? Now, another way to do it, guys, and I do this more and more lately, so that might mean that it's better because I don't tend to evolve towards chaos. In math, I tend to evolve towards what tends to be the easiest for me. I do more and more of this, and I didn't used to teach this, but I do more and more now. If you see a quotient, do a quotient rule. So if I have to take the derivative of that and it's a quotient, what would the low derivative of the high be? 0. So I'm not writing it. And then I'm going to go minus the high derivative of the low. What's the derivative of the low? 1 over the low squared. And then I don't have to move anything around, do I? I don't have to take that negative 2 and bring it back down the bottom. It's just ready to go. Look, negative 2 times that over the x squared. Bam. So I do that more and more is I just treat quotients like quotients, even if there was another way to simplify it, because we're better than just the power rule, right? I mean, we've got other rules. Yes, we are. Again, 23 is implicit. Don't worry about that. Look at 25. 25 says, which of the following is equal to the derivative of f of e? Now, what do you see? A bunch of limits. So what do you think they're using? The limit definition of a derivative. So let's just write out the limit definition of a derivative, but keep in mind there are 2 of them. Now the first one with f of x plus h minus f of x, what would that have looked like? So I'm kind of not looking at the answers directly right now. If that's the function, I would have the limit as h goes to 0 of what? F of x plus h. So if that's f of x plus h would be this, right? And then minus f of x would be this over h. But this isn't just the derivative of f of x. It's the derivative of f at what? E. That means that your x values there would have to be e's. So one option would be this. Do I see that? Yes.
Yes.
So I'm good. Now, if I didn't see that, I could use the other definition of a limit. The other definition says this: f of x minus f of a, which means the function at e, over x minus a. And this is not h to 0. This is x approaches a, which would be e. But I don't see that as an option. So the key to knowing it was going to be that first one is the h goes to 0. Because the other limit definition is this. It's f of x minus f of the a value over x minus the a value as x approaches the a value. And the a value is what you're taking the derivative at. So I saw h goes to 0, and I thought, okay, it's probably going to be that first one. So that's why knowing that definition is important, because this is the way they'd ask it. I got 2 minutes. We're going to call it a day, and that's pretty much the end anyway.
Does anyone have gum?
Yep.
Wait, did you say you did?
Nope.
It's not gonna be the steps.
Nope.
You want some?
Because you're the funny guy.
Yeah, guys, we will not do implicit differentiation.
Yeah, I was gonna say.
Well, at least as of right now. If I change the line, I'll let you know. But you don't have to do those implicit problems.
Somebody else. I looked at the lyrics.
You're tired?
No idea. I tried to grab it, but I think number 6. I got number 3 right. Or I think I got it. Number 6 is just it said
I think it's a Gaga bell. Oh, yeah.
Good day.
We played at the lake. It's like, and I like a little
Good
graphic.
day.
It's like a drawing. And then I try to get close to the other ball. Yeah. It's kind of like. Right, I was kind of.
they were not that way too small.
Yeah, I told him, I was like, unless you remind me, that means nothing to me.
I'm gonna try